Okay, for this video, I'll be going through static electricity tutorial. Okay, question 1. When a glass rod is rubbed with a piece of silk, explain in terms of movement of charges. So we need to explain in terms of movement of charges, especially electrons. Okay, try not to talk about protons. Okay, why the glass rod becomes positively charged. So you don't actually have to memorize whether the glass rod or the silk becomes positive or negative. Okay, so they will actually tell you that a certain object A becomes positive and object B becomes negative, and then you just have to explain in terms of movement of charges. Okay, so the answer is that as the glass rod is rubbed with a piece of silk, the electrons will be transferred. Okay, talk about electrons from the glass rod to the silk cloth due to friction, because this is they are both non-metals. Okay, so they have to go through charging by friction. Now the glass rod has less electrons than protons. Okay, please be mindful that after electrons were transferred, right, it doesn't mean that the glass rod don't have any more electrons. Okay, it just means that it has lesser electrons, therefore it becomes positively charged. Okay, so question 2 is also about the same. The man walking on a carpet and he's approaching a metal door which is earth. Okay, the idea of earth is that electrons can go up or down easily. Okay, so basically the earth has a large reservoir of electrons and protons. Okay, and so the earth will accept electrons and also give out electrons depending on the situation. Now when a person's shoes rub against the carpet, so they are both insulators, non-conductors. Okay, so charging by friction, his body becomes negatively charged. Again, you do not need to know whether object A or B becomes, do not need to memorize. Okay, so they are telling you that his body becomes negatively charged. So straight away, I can say the number of electrons is more than the number of protons. Okay, and the carpet becomes positively charged. That means number of protons is more than number of electrons. Now explain in terms of electrons, so you need to talk about the movement of the electrons, why the person's body becomes negatively charged. So the answer is that as the person's shoe rub against the carpet, electrons are transferred from carpet to shoes, alright, and the person's body due to friction. Okay, the body now has more electrons and protons, hence it becomes negatively charged. Okay, part B, when the person is close to the metal doorknob, okay, sketch the distribution of electric charges on the metal door. Okay, so we count, there are actually 1, 2, 3, 4, 5, 6, 6 electrons. Okay, so we should have equal number of protons here, 6 proton, take note. Okay, now where are the electrons on the other side? But maybe before that, why is it that over on the left hand side of the doorknob we have protons? Because we are supposed to just be talking about electrons, the movement of electrons, so the protons remain, right? So when this negatively charged object is brought near, the electrons in the metal doorknob will actually be repelled to the right hand side of the doorknob. Okay, and because like charges repel, okay, the electrons and electrons repel, so you cannot say that the protons are attracted to the left hand side. If you write that, then your answer is wrong. Okay, so now the electrons are repelled to the right hand side, and because the doorknob is earth, so they can enter earth, they will go down to earth because they are now repelled. Okay, so the answer is that electrons on the hand are attracted to the excess positive charges on the doorknob as unlike charges attract. Okay, so maybe I should talk about the electrons are repelled. Okay, so leaving behind excess positive charges. Okay, excess positive charges. Now upon contact, the electrons on the hand will be transferred to the doorknob because now they are touching, to neutralize the positively charged knob. Take note, you cannot say that to neutralize the positive charge. You can only talk about neutralizing the positively charged knob, the object, the charges on the knob. Okay, so you can only neutralize charged objects. You cannot charges cannot be neutralized. So I even have some students who will write they will neutralize the protons. Okay, so the protons cannot be neutralized, right? So now the person will experience a static shock due to the sudden discharge. You might want to write down this term, and both the body and the door becomes neutral. Okay, that means the excess electrons in the person is now able to go into the ground via the metal doorknob. Okay, question 3. Before this, okay, the diagram looks like this. Okay, so they actually wanted the metal can. Okay, by right the metal can, you should have a base. Okay, so maybe if you redraw it this way, okay, it will make more sense. Okay, the metal can, or it looks like this lah. So this is the metal can placed on an insulator. That means this metal can is not grounded via this way. Okay. However, it is now connected to a galvanometer to a earth water tap, so electrons can still move up or down depending on the situation. Okay. But what is a galvanometer? Galvanometer actually can measure the amount of electrons, hence current. Okay, so galvanometer, the symbol is like this. Okay, or G. Okay, so it's like your ammeter and voltmeter. Galvanometer, for this case, it is center 0. Okay, so if current passes through the galvanometer, is connected in series. Okay, if current goes this way, the galvanometer will deflect in the direction of the current. Okay. So if current now goes the other way, then the deflection will be the other way. Okay. So then some of you may ask, why don't you use an ammeter? Because galvanometer can just tell us that there is current flowing, and the amount of the movement of the needle will tell us how large the current is. So maybe I don't actually need the size of a current. Okay, or maybe the change in current is very rapid. Okay, either the current can be going left to right or right to left if it's connected to an AC source. Okay, so I don't really need the size or the magnitude of the current. I just want to know whether is there any current flowing. Okay, so on figure 3.1, draw the induced charges on the metal can. So the metal can, there is a certain thickness. So if my glass rod is placed inside, if my glass rod is going in to the metal can without touching any of the sides, okay, electrons will then be attracted to the inner side, leaving behind protons on the outer side. All right, and because this is Earth, okay, the electrons from Earth will actually come up, okay, and neutralize the positive charges. Okay, I must be careful here. Will neutralize the positive charges accumulated on the outer side of the can. Okay, so because the outer side of the can is positively charged, okay, so electrons will come up. Okay, so let's see the answer. The presence of the positively charged rod within the can causes electrons from the can to move towards the inner surface, right? As unlike charges attract. I think I need to emphasize on this. So this is a concept that is very obvious, but sometimes not mentioned, but it's needed. Okay. So in addition, electrons from the Earth are also drawn to the inner surface of the can. Okay, as electrons flow through the galvanometer, the current will cause a deflection. When the inner surface of the can is saturated with electrons, any additional electrons going towards the metal can will then be repelled as like charges repel. Okay, so there will be no more current flowing through the galvanometer, therefore there is no more deflection. So this part is the part whereby it is seldom answered by the student. Why is it only momentary deflection? Okay. Okay, part C, explain how you can produce an opposite deflection in the galvanometer using the same apparatus. That means you are still inserting a positively charged rod. So the action is to withdraw the positively charged glass rod from the metal can. So when the force of attraction is removed, the excess electrons on the inner surface will repel one another as like charges repel. And because it is earth, the metal can will become neutral. Okay, eventually the excess electrons flow back to earth and the metal cans becomes electrically neutral. So as the current flows through the galvanometer is in the opposite direction, right? Therefore, it will show a deflection in the opposite direction. Okay, question 4. Two vertical metal plates are connected. So metal is actually a conductor. They are connected to high voltage power supply. So we take note that here is plus, here is minus. Okay, and electric field exists in a space between the plates. So if this is the left hand side of the metal plate is connected to the positive terminal, so it will be positively charged, and here will be negatively charged. So you are supposed to be drawing the electric field. So 1 mark for direction, 1 mark for pattern. Okay, and take note that the lines cannot cut each other. Okay, and they are only asking you to draw in between, so you don't have to draw outside. Okay, and this is for figure 4.1, draw the line of force. Okay, so another question that you may need to know, or another concept that you need to know, is that what determines the direction of electric field? Okay, what determines? Okay, I forgot the exact question, but my idea here is that it is the direction of force experienced by a small positive test charge. Okay, small positive test charge. So now if I have a small positive test charge here, okay, the direction of the force that this small positive test charge will be is to the right, because it is attracted to the right plate, which is negatively charged. As unlike charges attract, it will be repelled by the positively left hand side plate, right? So the direction of the force will be the direction of the electric field. Okay, so state what is meant by the electric field between the plates. This one is in your notes. The electric field between the plates is a region where an electric charge experiences an electric force. Okay, just put into context in between the fields, so you can just write it here. Part B, an uncharged metal rod, and we take note that this is a conductor. Electrons can flow freely inside. It is hung by an insulating thread. That means it's not earth between the two plates, as shown in figure 4.2. So you need to draw on figure 4.2 the distribution of charges. Okay, and since the direction or the polarity of the plates are the same, so electrons will be attracted to the left hand side of the metal sphere, leaving behind the positive charges on the right hand side. Okay, and then we will then draw our field lines according to the direction and the pattern. Okay. Okay, so question 5, a large conducting sphere, so this is metal, mounted on an insulating pillar, so it is not earth, is given a positive charge. So the small uncharged metal sphere, again a conductor, suspended on an insulating thread is brought near. So the idea of earth is the idea of insulating thread or insulating stand is such that all the charges can be trapped there. That means if I have any charges here, the electrons cannot move in or move out. Okay, so that's the idea of a insulating thread, or sometimes they use a insulating stand. Okay, like this case. Okay, so show on the diagram the charges induced on S. So because it is a conductor, so we have electrostatic induction. So without even touching, okay, it can induce charges on S. So electrons will be attracted to the left hand side, leaving behind the protons on the right hand side. So this is the concept, but you only need to draw the charges induced on S. Now explain the observation why S is attracted towards X. So the answer is that when S is brought near the positively charged X, electrons within S are attracted to the left hand side, okay, causing the left hand side to be negatively charged while the right hand side is positively charged. There is a net attractive force between the sphere X and S. Why? As the force of attraction is greater than the force of repulsion. So the negatively charged side, which is the left hand side, is nearer to X, whereas the positively charged side, which is the right hand side, is further away. So although there is attraction and there's also repulsion, the attractive force is larger than the repulsive force due to proximity, okay, due to the distance between the spheres. Now part C, given that S now makes contact, explain what happens to S. Upon contact, some electrons from S are transferred to X. S becomes positively charged, and since X remains positively charged, repulsion occurs and S repels away. So you are, in this part, you are explaining using electrons. Okay, the motion of electrons, the transfer of electrons, but in the end, you still need to explain what happens to the object. Okay, I've seen some answers that says that S neutralizes object X. Okay, and this is not possible because S started off as neutral. Okay, and X started off with positive. There's no way that they both become neutral because it started off with a net charge. Okay. Okay, question 6.1 shows an electrostatic spray system. A positive high voltage, so this is positively charged, is applied to an electrode that is embedded in the spray nozzle to impart electric charges to the stream of droplets. Explain why the droplets are spread out evenly as they leave the nozzle. So as they leave the nozzle, being in contact with the positively charged electrode, the droplets will actually become positive, right? Because their electrons are attracted to the spray nozzle. Okay, so the positive charge imparted on the droplets lose electrons to the positively charged electrode, cause them to repel each other as like charges repel. Okay, so you need to have this. Explain in terms of movement of charges how the spray nozzle made the droplets positively charged. So as the droplets pass the nozzle, electrons are transferred from droplets to the positively charged nozzle. So even though the water droplets are not conductors, but the surface electrons will actually be transferred to the nozzle. Okay, as unlike charges attract, therefore the water droplets has less electrons than protons, making them positively charged. So this one will maybe be a 2-mark question. You need to talk about electrons are being transferred as unlike charges attract, and then less electrons than protons, therefore positively charged. Okay, part C, the diagram shows the positively charged droplets near the surface of a leaf, and this is the non-conductor. Okay, so on the diagram shows the charge distribution. So some of you will think that, oh, because it's a non-conductor, why would there be separation of charge? But non-conductor doesn't mean that there won't be separation of charge. It just means that the electrons cannot move freely. Okay, electrons cannot move freely in object, in the non-conductor. So if you have seen some demonstration using the balloon rubbing the hair, only the part that is touching the hair that's being rubbed will have electrons that's being transferred. Okay, and once the balloon is charged up, right, you put it near your hair, the balloon is charged up, you put it near your hair, there is still an attractive force. Let's say now the charges are accumulated on the balloon where it is rubbed over here. Now your hair having electrons and protons, the electrons will still move slightly to the left, being attracted as unlike charges attract. There will still be protons behind it. Okay, then the forces of attraction is larger than the forces of repulsion, right? Because of the proximity. Okay, therefore there will still be attraction. Okay, so this is how you draw the charges. Okay, electrostatic spray is able to provide a uniform deposition of droplets. Give another advantage of this system. The system allows the pesticide spray to cover a large area and more plants, right? So being this having uniform deposition, they repel one another, they can cover larger area. Now attraction between the positively charged droplets and the negatively charged upper surface of the leaf causes the droplets to attach firmly to the leaf. Okay, so we can, another way of this, another application of this electrostatic spray is spray painting of the car. Spray painting of car. Okay, so the paint will be given a charge, okay, and because they are light charges, they'll repel, okay, and they will actually spread out, and when they spread out, they will attach themselves firmly to the body of the car. Okay, question 7. It shows an electrostatic method of separating conducting and non-conducting spheres. Okay, so again, conducting spheres just means that electrons can move freely, and non-conducting spheres just means that the electrons cannot move freely. Okay, but it is connected to the positive terminal, so once they are in contact, electrons will be transferred. So this is the non-conducting sphere, it is blue in color. Okay, the conducting spheres are white, so the electrons within the conducting spheres will be transferred to the metal cylinder, right? So this conducting sphere will be positively charged. Okay, how about for the non-conducting sphere? The electrons on the outer surface will be transferred. Okay, so this guy, the non-conducting sphere, will also become positively charged. Now they both fall and touches the metal roller, which is actually earth. So if it's earth, it just means that electrons can go in or come out. Okay, that's all. So what happens to the conducting spheres? The conducting spheres, which is the one in white color, upon touching, electrons will then be transferred into them to neutralize the positively charged conducting spheres, right? So once it's neutral, it will fall because there's no longer a force of attraction. Okay, but for the non-conducting sphere, that area where it touches the metal roller, this side, it will be neutralized. It will be neutralized. However, this side, which is not in contact with the metal roller, will still retain their positive charge. Okay, so there will then be a force of attraction, and therefore they need to be scraped off. Okay, so by putting the two containers at different locations, I can separate the conducting spheres and the non-conducting spheres. Okay, but let's look at the answer. What happens to the spheres when they go through the metal cylinder, which is maintained at a high voltage? Electrons move from the spheres to the metal cylinder. They now have less electrons than protons, thus they become positively charged. So these electrons move, you can actually add in that as unlike charges attract. Okay, so why are the conducting spheres falling off from the roller while the non-conducting ones have to be scraped off? So as the positively charged spheres approach the metal roller, electrons move from the earth to the surface of the metal roller. When the conducting spheres touch the metal roller, they gain electrons. Electrons are transferred to them and they become neutral. They then fall off the roller under the effects of gravity. So this is the important part. The object becomes neutral. Okay. However, for the non-conducting, the electrons do not move readily in non-conducting spheres. Therefore, the spheres will remain positively charged. Only the area that is in contact will be neutralized. Okay, then they'll stay attracted to the negative charges on the roller and have to be scraped off.